class, does anybody make use of the recordings?
Yeah, I missed
Okay.
like the first week, so it was pretty useful.
Okay, so then we'll just continue recording the classes then. And oh, you know what? Every once in a while, all these little things show up at the bottom of my screen and they get in my way. I'm sorry. Okay, then the next thing that I wanted to ask before we get started is about the homework. Does anybody want to look at any problems from any of the homework assignments? Okay. And again, I think I've said it before, and I'm probably going to say it over and over and over again. If you're working on the homework and you have a problem, please feel comfortable using that Ask My Instructor button. One thing that I learned yesterday, because I know sometimes when I respond to people's emails, has anybody noticed if you don't have that toolbar, it's tough typing math? And so what I started doing yesterday is if somebody sent me a question, I wrote out by hand on the tablet what I would have previously typed in an email and sent it by hand, because I think it's easier for you to see if I can actually draw the symbols correctly. But if you have a question on the homework, please feel free using that email my instructor, ask my instructor function. Okay, are we looking at the assignment that's due on P3?
Yeah.
Okay.
This is number 11.
Number 11, okay. I'm sorry, the reason I'm using the headphones is because I was breaking up earlier and my internet is going ridiculously slow. We know there's a problem. Spectrum is coming to our house at 2 o'clock to fix it. So hopefully they give us a new modem or something. So question number 11.
Yeah.
What we've got here is the square root of 84 x to the 4th over the square root of 7x. Last class we talked a little bit about rationalizing the denominator. But before you even go there, let's look at those rules for radicals. We had said that this ratio of two radicals is the square root of the fraction, or I can just put them all under one big radical. And now as I look at that, do you recognize the fact that that fraction 84x to the 4th over 7 can be reduced? 7 goes into 84 12 times. X to the 4th divided by x to the 1st is x to the 3rd. Now as I look at that radical, I can simplify it. 12 can be thought of as 4 times 3. Because that's an odd exponent, x to the 3rd is not a perfect square. But I can think of that as x to the 2nd times x to the 1st. I believe last class we had said that with something like that, we could take out one factor. So now I can take the square root of 4, I can take the square root of x squared, but that 3 and that x to the 1st have to stay in. So my final answer is 2x times the square root of 3x. Okay or no?
Damn. Excuse me, but yeah, I'm just breaking it down step by step, that's all.
Okay, first thing, if I've got a radical over a radical, I'm going to put them together and see if I can simplify that fraction. If there were no radical there, where I've got 84x to the 4 over 7x, well, 7 goes into 84 12 times. And when I divide on the same variable, I can subtract the exponents. And so that's where this comes from. And now we just need to simplify that. To simplify a radical, what goes into 12? That's a perfect square, 4. Because this is an odd exponent, we take 1 away because we can take the root of an even exponent. Okay, any better?
Yeah, thank you.
Okay. If I talk too fast, just ask me to slow down. Anybody want to look at any others?
Could you go over question 28 again? I asked it
Any
last
homework?
class, but I just want to get some extra refreshers.
Sure. Actually, we haven't looked at fractional exponents yet. Can I leave this open and come back to it as an example
Sure.
in about 20 minutes, half hour?
Thank you.
Okay. And that's why I pushed that date back, because we hadn't looked at these problems yet. If it's all right with everybody, I'm going to, I don't want to get rid of you guys, but I need to get to that toolbar underneath you. When we left off last class, we were looking at rationalizing the denominator, and we looked at something like, what if I have, let's say, the square root of 5/7. And so we're going to change that into the square root of 5 over the square root of 7. And then can anybody remember what we had said we would do last class in order to get that radical out of the denominator?
Wouldn't we like multiply 7 by radical 7?
We're going to multiply.
5 by radical 7.
Right, we're going to multiply numerator and denominator by radical 7. Spot on, perfect. And so that gives me radical 35 over, if I take radical 7 times radical 7, if you want to, you can write that as radical 49. But then when I simplify that, don't I just get 7? If I multiply a radical by itself, if I square a square root, it undoes it. And so I just get what's underneath. And so this is considered simplest form. And I can't remember how many of examples like this we did last class, but I believe that was where we left off, rationalizing the denominator, if there was just one thing in the denominator. Is everybody comfortable with that?
Yeah, this one actually made a lot more sense. Yesterday I was on this problem and I was I did like everything. I still couldn't find it, but this makes more sense, so thank you.
Okay, you're welcome. And again, if homework's not making sense, please use that Ask My Instructor button. I don't want anybody to ever get frustrated and struggle with the homework. I've been falling asleep early, and also I'm going to give you a heads up this weekend. My husband and I are going to be going out of town to visit our new grandson. So I will check email, but probably not as frequently as if I were at home. But where we're going next today then is we're going to look at rationalizing the denominator. We're going to look at problems that are a little bit different. We're going to say what happens if there are two terms in the denominator. So my example, what if I have 1 over the square root of 3 minus 1? There's something extra down there, isn't there? There's two terms in that denominator. We've got a radical in the denominator, so we cannot leave that like that. We have to get that radical out of the denominator. Any ideas? Does anybody have any thoughts as to what we might be able to do to rationalize that? Usually, when I ask that question, based on what we've done before, that's radical 3. There's always somebody who says, well, why don't we multiply top and bottom by radical 3? And if I do that, top, 1 numerator, 1 times radical 3 is radical 3. But does everybody see that in the denominator, I'd have to distribute? Distributing radical 3 times radical 3 is going to give me 3. So that's out of the radical. But over here, when I take radical 3 times 1, don't I still have a radical left? And so that's not going to work. We can't just multiply numerator and denominator by a single radical. Instead, we have to introduce an idea that's called the conjugate. and we're going to look at conjugate pairs. And before we look at conjugate pairs, I'm going to go on the assumption that this is not the first algebra class for anybody. While we haven't really started looking at polynomials yet, I'm going to ask, does anybody remember what happens when you multiply something like a plus b times a plus b? When you multiply if they're same terms, but one's got a plus sign and one's got a minus sign. Does anybody ever remember ever multiplying something like this out before?
Yeah,
Yes.
doesn't something cancel?
Yeah, something cancels. If we were to multiply this out, do you guys remember, are you FOILers? Do you use FOIL to multiply? Or did you folks learn a box method?
Box method.
Okay, I'm hearing both, so we'll do this both ways. If I were to FOIL, let's do that first. A plus b times a minus b. F stands for the first in each. A times a is a squared. O stands for the outside edges, would give me minus ab. I stands for the inside, the ones in the middle, would give me plus ab. L stands for the last two, which gives me minus b squared. Minus ab plus ab would cancel, and I'm left with a squared minus b squared. If you're not a FOILer, you're probably a boxer. And if you're a boxer, this might look more familiar. A times a is a squared. A times b is ab. A times, I'm sorry, one of those was a minus sign. I apologize. A times minus b is minus ab. A times plus b is plus ab, and b times b is minus b squared. And so when you add along your diagonals, those cancel out, and you're left with a squared minus b squared. And so if these are considered a conjugate pair, we're going to say that a plus b and a minus b are conjugates. And their product if I take a plus b times a minus b, that will always multiply to the first one squared minus the second one squared. Does that look slightly familiar? The product of the sum and difference gives us the difference of the squares. So, can I turn the page?
Yep.
So, if I have that radical 3 plus 1, its conjugate is going to be radical 3 minus 1. And because I know they're conjugate pairs, to multiply them, it's the first one squared, so that's radical 3 squared, minus the second one squared, 1 squared. And so radical 3 squared is 3, 1 squared is 1, and so I get 2. And so if I have a binomial conjugate expression, in order to get rid of the radical, I need to multiply by the conjugate. I have a binomial radical expression. To eliminate the radical, I have to multiply by the conjugate. So if I go back to that first example that we decided we couldn't do the way we were doing the others, where I have 1 over radical 3 plus 1. If there's a binomial radical expression in the denominator, I'm going to multiply both the numerator and the denominator by the conjugate of the denominator. So we've said it over and over. We've got kind of wordy about this. Let's see it in practice. My denominator is radical 3 plus 1. The conjugate is going to be radical 3 minus 1. And again, whenever we do this, we're trying to change the way it looks, but we don't want to change what it equals to. So we're always going to be multiplying by 1. And we're going to write that 1 as a fraction with the same thing in the numerator and the denominator. We want to make sure we always do that because that way we're only multiplying by 1 and we're not changing the value. When I do this multiplication, 1 times radical 3 is radical 3. Got to distribute here. 1 times minus 1 is minus 1. And because they're conjugates in the denominator, I'm going to have again the first term squared minus the second term squared. So that'll give me my radical 3 minus 1 over squaring those would give me 3 minus 1. And my final answer is radical 3 minus 1 over 2. How's it look? Shall we try a few more, or do we need to wait a minute?
Try a few more.
Okay. Let's look at radical 7 over radical 5 minus radical 2. With a fraction like this, there's nothing common. We can't reduce it. And we've got those 2 radicals in the denominator. That's what we're going to worry about, the radicals in the denominator. In order to get them out, we need to multiply by the conjugate. What would the conjugate of radical 5 minus radical 2 be?
Radical 5 plus radical 2.
Beautiful. Radical 5 plus radical 2. I like it. Are we all in agreement with that?
Yep.
Now, we've got 2 products that we have to take. I'm going to do the numerator first. And again, see, we've got to do the same thing, numerator and denominator. In the numerator, I'm going to distribute. Radical 7 times radical 5 will give me radical 35. Radical 7 times radical 2 will give me radical 14. Is everybody all right with the numerator? Sometimes when you do that, those radicals can be reduced, but I wouldn't reduce that until the very end. A lot of times they can't be reduced. Now in the denominator, because they're conjugates, I'm going to just take the first term and square it minus the second term squared. So that would give me 5 minus 2. So that denominator is 3. So my final answer here would be the square root of 35 plus the square root of 14 over 3.
I get lost right there when you said 5 radical square minus 2 radical square equals 5 minus 2. How did you get 5 minus 2 from that?
Okay, let's look at each piece of that. If I take the square root of 5 and square it, are you all right? That means the square root of 5 times the square root of 5, which would be the square root of 25, which is
5. Okay.
In the same way, if I were to take the square root of 2 and square it, it's the square root of 2 times the square root of 2, which would be the square root of 4, which is
2. Okay, I see. Thank you.
So in general, if I have the square root of a and I square it, I'll always get a. When you square a square root, it's just like taking its head off. It undoes it. Thank
Gotcha.
you for asking. Better?
Yes.
Should we try another one?
I have a question.
Sure.
So when the final answer is radical 35 plus radical 14 over 3, would you
Yes.
want us to leave it like that, or would you want us to find the largest square out of like 35 and 14 and then leave it like that?
If there were a largest square in 35 and 14, you could. But I look at 35 and that's 5 times 7. Neither of them are square. I look at 14 and it's 2 times 7 and neither of them are square. So I stopped there because I knew in advance it couldn't reduce. But if,
Yeah,
it, if it were, instead of the square root of 35, if that were, let's say, the square root of 32, then yes, you would have to reduce that.
Okay, thank you.
Okay?
Yes,
So
thank you.
you're right. Yes, you do have to simplify, but neither of those ones do. So I think
Okay.
you're saying the same thing. Okay?
All right, thank you.
All right. So next one, let's look at 15 over 3 plus the square root of 17. And this one, I'm going to shut up for a while. Actually, I'm going to be really bad. And does everybody have that problem written out? While you're working on that, I'm going to cheat for a second and scroll through the notes from the preceding section because I want to make sure I do this, the next example, I do the same one with you that I did with them, and I forget what I did with them. So give me a second, okay? But work that one out on your own. Tell me what you get. Got it. How'd you guys do? Did anybody else get 45 minus 15 radical 17 over negative 8?
Yep.
Yep. Anybody have any questions or are we good?
Very good.
Good. Okay, next one's just a little bit dicier. What if I have 1 plus radical 2 over 1 minus radical 2? Let's do this one together because it is just a little bit different. What's similar is that we've got a binomial radical expression in the denominator. We have 2 terms in the denominator and at least one's got a square root. We're going to do the conjugate of the denominator. So the conjugate in the denominator, that's going to multiply to 1 squared minus radical 2 squared, which will be 1 minus 2. So my denominator is negative 1. And that part's the same as what we've been doing so far today. Where it gets a little bit different is in the numerator. In the numerator, because I'm multiplying two terms by two terms, when I have that in the numerator, if I have two terms, 1 plus radical 2 times 1 plus radical 2, you have to either FOIL or box, or some people might distribute twice. But you have to multiply that all the way out. I'm a FOILer, so first 1 outer plus radical 2, inner plus radical 2, last radical 2 times radical 2 is 2, gives me 3 plus 2 radical 2. If you're a boxer, we've got 1 plus radical 2 times 1 plus radical 2. 1 times 1 is 1. 1 times radical 2 is radical 2. 1 times radical 2 is radical 2. Radical 2 times radical 2 is 2. And so it takes us to the same place. So here in the numerator, I have 3 plus 2 radical 2. And then dividing by negative 1, my final answer would be negative 3 minus 2 radical 2. And so I believe that most of the ones that you're going to see in the homework only have that one term in the numerator. If there is a second term in the numerator, be careful. You have to, there are no shortcuts. You have to multiply it out. So everybody all right wrapping their minds around that idea of conjugate pairs? Is that one okay? I get real worried when I get silence. You guys all right?
Could you do one more about this problem?
Sure.
I was going to say the same. Could you do one more?
Okay.
Thank you.
Let's say we've got radical, let's say we've got radical 15 plus 1 over 4 minus radical 15. Help. What's first? I'm waiting.
At the top, shouldn't it be 4 plus radical 15?
Times 4 in the both the top and the bottom. I like
Yes.
that. Conjugate pair. Bottom's easier. Is everybody all right if I do the easier half first?
Yes.
Because they're conjugates, it's going to be 4 squared minus radical 15 squared. So the denominator is going to be 16 minus 15, which is 1. In the numerator, I'm going to FOIL. Some of you might box. FOIL, going to multiply the first terms. Radical 15 times 4 is 4 radical 15. Outer, radical 15 times radical 15 would give me 15. Inner, 1 times 4 would give me 4. Last, 1 times radical 15 would give me radical 15. Like terms, 15 plus 4 is 19. 4 radical 15 plus 1 radical 15 is 5 radical 15. So my final answer is 19 plus 5 radical 15. So again, when we pick what to multiply by, we're focusing on that denominator. We're taking the conjugate of the denominator. What makes it the conjugate is the opposite sign. We do that because it will always multiply to the first one squared minus the second one squared, which will always get rid of our radicals and give us a single number in the denominator. If there's only one term in the numerator, we just have to distribute. If there's two terms in the numerator, we have to distribute twice, which is what FOILing does. And again, I think some of you told me you're more comfortable boxing. If you're a boxer, radical 15 plus 1, 4 plus radical 15 gives me 4 radical 15 plus 4 plus 15 plus radical 15, which are the same terms that we got FOILing, and you go to the same place. That one okay? If so, we're going to change gears just a little bit and look at some other roots. I want you to remember that we said the square root of A equals B means that A is B squared. If I want an other root, I'm going to have something like, there'll be in the check mark in the upper corner, upper left-hand corner of my radical, there will be a number. And this is the nth root of A equals B. N is called my index. A is still called my radicand. And what I'm getting is the nth root of A. And what that means is that A is equal to B to the N. So when I'm taking the square root, I'm actually taking the second root. We're going to be looking at other roots. I'm guessing that some of you might have previously heard of something like the cube root. If I look for the cube root of 8, I'm wondering what number I can raise to the third power and get 8 as my answer. Well, 2. 2 to the third is 2 times 2 times 2, which gives me 8. So the cube root of 8 is 2. Now, that's an odd index. Would I be able to take the cube root of negative 8? Is there something I can multiply by itself 3 times to get negative 8? Well, if I took negative 2 times negative 2 times negative 2, I would get negative 8. And we're going to find that if the index is odd, the radicand can be negative. And the root will be negative. So, looking at a couple more, if I were to ask for the fourth root of 81, again, I'm wondering what number to the fourth power gives me 81. And is there something that I can multiply by itself 4 times and get an answer of 81?
3.
3. 3 times 3 is 9. 3 times 3 is 9, and 9 times 9 is 81. So the cube root of 81 is 3. So what if I ask for the fifth root of 32? Is there a number that I can raise to the fifth power and get 32 as an answer? You can get this by trial and error. 1 to the fifth, 1 times 1 times 1 times 1 times 1 is 1. 2 to the fifth would be 2, then 4, then 8, then 16, then 32. And so that would give it to me. I don't know how comfortable you folks are with your multiplication facts. I know it's sort of a generational thing, and some people are better than others, but I'm going to stop sharing for a minute. And I'm going to hold up my calculator. And as you look at my calculator, I'm seeing somebody else's screen. Can you guys see my screen?
Yep.
As I look at my calculator with this model, I'm going to look above x squared is the square root symbol. Then above the caret up, there's a square root symbol with a little n in the corner. That means I'm looking for the nth root. So for example, when I just looked for the fifth root of 32, I'm going to press 5, then I'm going to press second caret up, and that opens that radical with an index of 5. Then I'm going to put in my 32, and when I hit equals, it gets me to that 2. If what you get is a decimal, then it's not a perfect root, and you're going to want to look at simplifying it. But is everybody okay? If you're not comfortable with finding that 2 other means, it is something you can get those other roots from your calculator. So now I'm going back to sharing my screen. The next fifth root of 32 is 2. So, how far down are we? Yeah, let's make a fresh page. The rules that we had for radicals hold for other roots as long as the indices are the same. Grammatically, that's incorrect. Plural of index should be indices. So if I have the nth root of A times the nth root of B, that'll give me the nth root of AB. And likewise, if I have the, oh, I apologize, I miswrote. If I have the nth root of A over the nth root of B, that will be equal to the nth root of A over B. So how is that going to work? Let's say I have the cube root of 7 times the cube root of 49. Because they have the same index, I can multiply to get the cube root of 7 times 49. If you're a glutton for punishment, you'd multiply that out. That gives me the cube root of 343, which turns out to be 7. I'm a little bit lazier, so rather than doing that much work, does everybody recognize that 49 is 7 squared? And so that would give me the cube root of 7 to the third, which would also give me my 7. Oh, I don't want that to disappear. I'm sorry, I poked at that one because I thought it was somebody asking a question. Another example. If I have the fourth root of 162 x to the fifth over the fourth root of 2x. As I look at these, does everybody notice they have the same index? And so I can combine them into a single fraction, 162 x to the fifth over 2x. We're going to keep the fourth root. 162 divided by 2 is going to be 81. X to the fifth divided by x to the first is x to the fourth. And then I believe we already noticed that the fourth root of 81 is 3. And then what would I raise to the fourth power to get x to the fourth? Just x. And so that result would be 3x.
Wait, how'd you get that? Could you explain the last part from when you went to equals 4 over radical? I just want to know how you got that 3. That's how
Okay, I'm going to erase it and redo. Are you all right with, whoa, with where the 81 and the x to the fourth came from?
Yep.
Okay, so what we're doing is we're taking the fourth root of 81 times the fourth root of x to the fourth, using that x to the fourth, pardon me, using that product rule backwards. What number to the fourth power gives me 81? I think we looked at that as an example already and said it was 3. And then over here, what would I raise to the fourth power to get x to the fourth? X. And believe it or not, this second part, simplifying the root of a variable to a power, gets easier if we introduce the idea of rational exponents. Before we do that, is that one better now?
I have
Yeah,
a question.
Sure.
So on our homework, are the questions gonna, like, is this the hardest that it's gonna get? Because I've noticed, like, you'll give us the easy ones and go over it, and then I get to the homework and it's like
The
double.
homework is intentionally a little bit more challenging than the notes because there's something that's called productive struggle, and it's a big dealio in education circles now, where if you have to work a little bit harder on the homework, you're going to remember it more. But because of that, that's why I keep saying, if you need help with the homework, please ask. If you want, when we're through with the next couple things, we'll stop and we'll go through some of the ones from the homework for you, starting at the back and working our way forward. All right?
Yes, thank you.
So what's going on over here actually becomes easier if we look at rational exponents. And when I look at rational exponents, oh, sorry, folks, I'm trying to shut that off. Sorry about that. Rational exponents, I mean when I have a fraction as an exponent. So what we're going to do now is we're going to give meaning to x to the m over n. What does it mean if I have a fractional exponent? Rational exponents, if there's a fraction in the exponent, it means I'm going to have a radical. The denominator of the fraction is the index,
Radicand or radical?
radical. Thank you. The denominator is the index, and then the numerator becomes an exponent. So here, n would be the index of the radical, and m will be an exponent. So where I have x to the m over n, that means I'm going to draw a radical. The base is the radicand. The denominator is the index. And the numerator, I can think of it either as the exponent on the radicand, or I can think of it as the nth root of x, all being raised to the n power. The numerator is an exponent. So for example, if I look at 8 to the 1/3, that's going to be, it's a fraction, I'm taking a root. The denominator of the fraction is 3, so I'm taking the cube root of 8 to the 1st. And the cube root of 8 is 2. I would feel remiss if I didn't take a little bit of time to explain why that's the case. So I want to look at this from two sides. We're saying that the cube root of 8 is 2. And we said that that means that 2 to the 3rd is 8. Well, on the other side, if I take 8 to the 1/3 and cube it, it's an exponent. So my exponent rules stay. They're the same as they were before, even when we had natural number exponents. Does everybody remember when I raise a power to a power, I multiply those exponents? And so when I take 1/3 times 3, I get 8 to the 1st, or 8. And so since when I raise that to the 3rd power, I get 8, that is the same as the cube root of 8. And that's a little bit of the why. Let's look at another example. What if I have 81 to the 3/4 power? First of all, because we have a fraction in the exponent, is everybody comfortable with drawing a radical? The
Yeah.
denominator is 4, so I'm going to take the 4th root of 81. The numerator is 3, so after the fact, I'm going to cube that. So inside parentheses, what number to the 4th power gives me 81? I think we've used that as an example a couple times today.
3.
That's 3. And 3 to the 3rd would be 3 times 3 times 3, which is 27. I usually find it easier if I take the root first before I do the exponent, but we said it worked both ways. I guess if you really, really, really like big numbers, we could have thought of that as the 4th root of 81 to the 3rd. And so that would give me the 4th root of, and I have to apologize, I'm going to be a little bit mentally lazy here and not try to take 81 to the 3rd by hand. If I raise 81 to the 3rd power, I get 531,441. God, that's a big number. And then if I go through and take the 4th root of that answer, it still takes me to 27. And so the order in which you do it doesn't matter. But does everybody notice that if you take the root first and then raise it to the power, the numbers don't get quite as scary? So let me this page out. I'm going to turn the page so that these pages don't get too terribly long, if everybody's all right with that.
Yes.
So I'm going to ask you folks to please evaluate for me 36 to the 3 halves. On the quiz and in the homework, the first thing I think they ask you to do with this before you evaluate it, I think they say evaluate without a calculator. And I mean, even with the tests and quizzes, you're going to be able to use a calculator. Ooh. Go away. I don't mean you guys go away, I mean that pop-up. Could everybody rewrite that as the second root of 36 to the third? The second root of 36
Yep.
is 6, and 6 to the third power, if I were to take 6 times 6 times 6, I get 216. What's important that you're going to need for the rest of your mathematical career, especially if you're on this boat through pre-calculus, calculus, and beyond, this ability to take a radical and write it as a fractional exponent is important. This step here, going from 36 to the 1/3, I'm sorry, from 36 to the 3 halves to the square root of 36 cubed. Is everybody all right changing the radical into a fraction or the fraction into a radical?
Yep.
In terms of evaluating, do I really want to do this? Did you guys want to see? You could just evaluate that with the calculator. If it's going to come out to be a rational number, you could take 36, use your caret up button for the exponent. But what's important is if your exponent is a fraction, you put it in parentheses, 3 divided by 2. So that your calculator will evaluate fractional exponents. But just make sure if you're doing it with a calculator, you put that exponent in parentheses. Next one's more fun. What if I have 16 to the negative 5/4? What's different with this one?
There's a negative this time.
Yep. And what does a negative exponent tell me I have? A fraction. And that'll be 1/16 to the positive 5/4. That step all right. Negative exponents mean fractions.
Yep.
Then that fractional exponent means I'm taking a root of 16. The denominator is the index. The numerator is an exponent. So what number to the 4th power gives me 16? Will you trust me that it's 2? And then when I raise it to the 5th power, my final answer would be 1/32. And so backtracking, when we had earlier the 4th root of x to the 4th, we could think of this as x to the, well, we rewrite that with a fraction, 4/4, which would give me x to the 1st, or just x. If I asked you to simplify the 9th root of x to the 6th, if I were to rewrite that as a fraction, the exponent goes in the numerator, the index goes in the denominator, and so I've got x to the 6 ninths. Can anybody reduce the fraction 6/9?
2/3.
So that's x to the 2/3. And so we can rewrite that as, that's the index, the cube root of x squared. Interesting?
Yeah.
So what if I ask you to simplify 2y to the 1/5 to the 4th over y to the 3/10? How's that look? Even when you have fractional exponents and negative exponents, your exponent rules still hold, as do your order of operations. So the first thing that I would do here is I would clear that outer exponent in the numerator. And in order to do that, does everybody remember when I raise a product to a power, I raise 2 to the 4th, and I raise y to the 1/5 to the 4th. 2 to the 4th is 16. And now I guess I want to know, can anybody remember when you raise a power to a power, what do you do with those exponents?
You multiply.
Right. And so when I take 1/5 times 4, I get y to the 4/5. So that numerator becomes 16y to the 4/5. And my denominator is y to the 3/10. Now, I have the same base here, y and y. When I divide, what do I do to the exponents?
Subtract.
Subtract.
No, we're going to take 4/5 minus 3/10. And I can't force you to do it by hand. Some of you might be more comfortable doing the fractions by calculator. But I'm going to do it by hand. Does everybody remember, in order to subtract fractions, I need to have a common denominator. Between 5 and 10, it would be 10. This first fraction, I'd have to multiply by 2/2, which gives me 8/10 minus 3/10. Now that I've got the common denominator, I'll subtract the numerators, 5/10. And can anybody reduce 5/10 for me?
1/2.
A half.
Yeah. And so that becomes 16y to the 1/2. Or I could write that as 16 because that's a fraction. I'm taking a root. The index is 2. If the index is 2, it means it's the square root, and I don't have to write it. But I can think of that as the second root of y to the first, or that's just 16 radical y. How fun is that?
Would it be better to write it 16y to the 1/2 or 16 to the square root of y?
When you're doing these in the homework, when you're working in my math lab, you're going to find underneath where you put the answer, they'll tell you what form to write it in. They'll either say express it as a radical, in which case you want the square root of y, or they'll say write it with exponents. And it says the exponents can be either fractions or integers. They'll always say non-negative exponents though. So what's best is what the directions ask you for. If we were in a traditional class and we were taking pencil and paper tests, I would accept either because they're equivalent. On the internet with the homework, they will tell you what form to put it in. They'll either say write it with a fractional exponent or they'll say write it with a radical. Okay? So I'm going to do both so that you guys get comfortable with the idea that the two are interchangeable.
I have another question.
Sure.
On any homeworks or tests, like in the future, is there ever going to be like a radical exponent?
Do you mean like if I have
Like-
16 to the square root of 3?
Yeah.
Okay, I don't think you're going to necessarily see that in this class. You might see that in your next class if you take Math 110. But something like this, if I have an irrational exponent, that is going to exist. And the only way in which you're going to evaluate that is you're going to evaluate that with a calculator.
Okay.
And so with a calculator, I would type that in as 16 raised to the square root of 3 power, and you'll get a decimal approximation. I have a couple more examples here that I have written out, but I promised I'd go back to that one from the homework. And damn it, I thought we had more time. But let's look at this one kind of quickly.
What number is this? 28?
Yep, this is 28. I didn't forget that I promised. You had 32x to the negative 5, y to the 10, to the negative 1/5 times xy to the 1/5. Yikes. Power to a power. I'm going to take everything inside the parentheses and raise it to the power. So that would give me 32 to the negative 1/5. X, when I raise a power to a power, I multiply those exponents. Negative 5 times negative 1/5 gives me positive 1. Y, 10 times negative 1/5 would give me negative 2. And then I'm going to multiply that by xy to the 1/5. Over here, number part, 32 to the negative 1/5 is 1 over the 5th root of 32. And so that's just a fancy pants way of writing a half. X to the first times x to the first is x to the second. Now here, y to the negative 2 times y to the 1/5, that would be y to the negative 2 plus 1/5. And in the interest of time, will you trust me that that addition would give me y to the negative 9/5? Now I'm going to look at that fine print. Simplify your answer. Use integers or fractions for any number in the expression. Type your answer using exponential notation. So over here, they're telling me to leave it as a fraction in the exponent. Use positive exponents only. And damn it, we've got a negative exponent here. So I'm making a fraction. The 2 is in the denominator. The part with the negative exponent, it will become positive when I move it to the denominator, and the x squared stays up top. And so with that, if you got to this point here, using our exponent laws, what we hadn't done before was say what those fractional exponents mean, which is taking a root. But this question says that I can leave it with a fractional exponent. However, I believe if you leave it as 32 to the 1/5, that they want you to simplify to the numeric coefficient. Does that answer your question about number 28?
Yes, it does. Thank you.
And that was why I kicked the can down the road, because I knew we hadn't done them yet. Whomever was saying that the homework problems are a little bit more involved than the examples in class, I think this is about as involved as they get on that homework. There's only one problem after it. Let's see, is that one a little bit, well, I got to turn my finger into a mouse. Is that one a little bit more involved? Not too much. All right. So we're using the rules of exponents. It's just that the exponents can be fractions. If the exponent is a fraction, it means I've got a radical. All right. By my clock, it's 1:46. So I'm going to stop sharing my screen. I guess I'll stop recording.